It's my great pleasure to introduce this next presentation on the Scott Base Redevelopment Project by Simon Shelton, Antarctica New Zealand.
Hi, I'm Simon Shelton, the Senior Project Manager for Antarctica New Zealand, and I'm working on the Scott Base Redevelopment Project.
Hi, I'm Hugh Broughton of Hugh Broughton Architects, and I'm the Design Director for the Scott Base Redevelopment Project.
Despite Hugh and I being geographically separated due to COVID-19, today we're going to share the presentation and show you all about our project. This image is of the existing Scott Base on Pram Point, Ross Island in Antarctica. The current base comprises of 12 interconnected buildings. Commissioned in the mid-1980s, it can accommodate up to 86 people and operates 24 hours a day, 7 days a week for 12 months of the year. The current base is the second base at Pram Point. The first New Zealand base was established in 1957 for the Commonwealth Trans-Antarctic Expedition and led by Sir Edmund Hillary with support from the Ross Sea Committee. It was designed by Frank Ponder from the Ministry of Works and constructed under the leadership of Randall Hickey. It sits at 77 degrees south under the shadow of Mount Erebus, which is the southernmost active volcano on Earth. Pram Point is approximately 4 kilometres from McMurdo Station. Both the US and New Zealand stations operate off a shared energy grid that utilises renewable energy from 3 Enercon E33 wind turbines. Pram Point is surrounded by sea ice that can break out on average every 3 to 4 years. Whilst the current base has served Antarctica New Zealand and its users well, it is deteriorating and no longer fit for purpose. In response to this, the Scott Base Redevelopment Project was initiated in 2016 and is the largest project ever undertaken by Antarctica New Zealand. The Scott Base Redevelopment Project is in the third of 4 stages of design before construction is due to commence in the 2022-23 season. There are several issues within the current base that determine the case for change. Accessing infrastructure can be almost impossible in some circumstances as it is housed in tight underfloor cavities. Many of the base's engineering and life support systems are now operating well beyond their intended design life. Housing people in basic shared accommodation where noise transfers between the hallway and rooms makes sleeping difficult and fatigue sets in. Some have to sleep outside in modified shipping containers at times of peak demand for accommodation. Because of the long lead time to address all of these issues, it is critical that we move forward with a suitable redevelopment plan. In 2017, we formed a project team to deliver the Scott Base Redevelopment Project. Due to the requirement of specialist polar experts, the team comes from all around the world. We also work closely with other national Antarctic programs to share information and learn from each other. We are approaching the final stage of design, which is called detailed design. It's a very exciting and important stage where we confirm the details and ensure the design is fit for purpose, meets the project budget, and is able to be constructed in Antarctica. I'm going to hand over to Hugh to discuss the design and its evolution now.
In 2017, we began developing designs for a new Scott Base. These sketches show some of our initial ideas. Over time, one idea emerged as the optimum solution. The concept was simple. 3 buildings of matching width and shape step down the hill of Pram Point. The buildings are connected by link bridges. In this way, the lower level of the top building connects to the upper level of the middle building, and the lower level of the middle building connects to the upper level of the lower building. This is an aerial view of the existing base, which will be transformed into this, with the new base stepping down the hill. The top building is the main accommodation containing bedrooms, dining space, recreation areas and the main entrance. The middle building contains science staging areas, labs, offices and administration functions. The lower building contains engineering workshops and warehousing. Plant is distributed through the buildings in an arrangement which maximizes resilience. The layout has been developed to minimize environmental impact. Despite being located in Antarctica, there are a surprising number of factors which have impacted on the location of the buildings, from the position of the road from McMurdo to the coastline, the location of long-term science instruments, rare flora which grows on the hillside, and the overall irregular sloping topography of the site. We're still working on the optimization of the site layout to minimize the amount of disturbance to the ground. The design will provide linked, communal and collaborative space to support people's well-being and help them to feel culturally connected both to Antarctica and to New Zealand. It will be efficient, safe to operate, resilient and highly sustainable, making best use of wind energy to reduce the use of fossil fuels, and above all, it will provide excellent facilities to support world-class science. Each of the buildings has the same cross-section. They are steel-framed. Zones have been created to facilitate service distribution and ease maintenance. The buildings have monopitch roofs and a chamfered leading edge to reduce wind drag. They are also elevated on legs at least 1 metre above the ground, so that the wind accelerates underneath, preventing snow from accumulating under the buildings or in their immediate vicinity. This concept was tested in a laboratory in Canada. Models of the existing base and the proposals were placed in a flume of water. A current was created within the water and then fine sand was introduced. This simulated the snow and ice which are blown across the sea ice from the southwest. As the sand passes over the buildings, it drops out of the current in the same way that snow drifts around buildings. We modelled the existing base so that we could benchmark the process and make sure it properly represents what happens at Scott Base. We then tried different permutations of the designs to arrive at the optimum arrangement of buildings to minimise drift and therefore snow management. The design fuses pragmatism with a desire to create a home from home for the residents and a building which captures the spirit of New Zealand. The entrance is welcoming with views into the building. On entering Building A, visitors will be welcomed in a dedicated lounge where they will receive their induction in a pleasant space lined in timber and with views out into the landscape. The main entrance corridor will include displays to explain the history of Scott Base, of New Zealand's expeditionary endeavours in Antarctica, and of the great explorers who first visited Ross Island over 100 years ago. The dining room and bar upstairs have fantastic views through a panoramic window to the pressure ridges of the Ross Ice Shelf and Mount Erebus, the iconic volcano on Ross Island. At the far end of the accommodation building, there is a library with views to Mount Discovery. Wherever possible, we have considered the experience of living at Scott Base and ways to make life as comfortable as possible for the residents. Longer-term residents will have a single bedroom with views into the landscape. Each bedroom includes plenty of storage space, blackout blinds, lighting to support circadian rhythms, a desk or comfy chair and places to pin up pictures. Shorter-term visitors will be accommodated in twin or pod-style rooms. Great emphasis has been placed on the acoustic comfort of the residence, which has been designed using a laboratory process to simulate the likely level of noise transmission from one space to another to ensure maximum privacy. Building B is dedicated to science activities. A large science cargo handling area allows expeditions to gather their equipment together before heading into the field. Cleaner workspaces along the edge allow scientists to prepare electronics or calibrate equipment. Upstairs, there are offices for managers, field operatives and visitors, as well as training rooms, meeting spaces, tea points, a printing station and the main comms room. The offices are as open plan as possible to foster collaboration. There are also a series of labs, shown behind the glass screen on the right, with suitable services to support as many scientific activities as possible. The lower of the three interconnected buildings contains workshops and warehousing. It also houses some of the main plant spaces, including the wastewater treatment plant. Generators, boilers and water production are split between this building and the accommodation building to maximise the resilience of the base. The cladding combines metal composite panels to the main body of the buildings with composite glass fibre panels to the areas with more complex geometries, which need to be curved to minimise the impact of the wind on the structure and snow deposition.
The structure is made of steel, designed to the same standards as a public hospital in New Zealand. It is simple in principle, utilising a regular, repeatable frame. The structure must be able to withstand transport loads as well as dynamic and static loads once constructed. We investigated many ways in which the new base could be built. These ranged from prefabricated components transported in shipping containers through to moving whole buildings in one go. We are currently proposing to build the base in New Zealand and transport it to Antarctica in large modular sections using specialist equipment. This slide shows a typical construction sequence in which the building would be formed. This work would be completed in New Zealand, with the buildings being fully commissioned before it is transported to Antarctica. The proposed vessel for moving the large modular sections is a polar-rated MC-class vessel. The modules would be moved using self-propelled modular transporters. This method has been used extensively in industrial projects and proven in the Arctic environment. Thank you for your time. Please do get in touch if you have any thoughts on the ideas within the presentation. We do value two-way feedback and sharing Antarctic experience and engaging with other national Antarctic programs. We're very open to sharing information program to program. Please do get in contact with us at sbrproject@antarcticanz.govt.nz or visit the website for the latest information.